All right, here we go. So 5.2 technically has two things to it. It's got Incenter and this other thing called centroid. In the last class, like I said earlier, we only got to the Incenter part, so I think we'll do the same thing today. Might actually even finish early, give you a chance to work on your homework. All right, so we'll call this 5.2a, we'll just call it Incenter. And this will be on the quiz that is on Friday. All right, so make sure you're aware of that. Okay, let's talk about a word before we even deal with this Incenter thing. Let's talk about a word. And part of this word is something that you've already done. And we've talked about, so... All right, so what do I got right there? What is that? That thing that I drew, what is that? That's an angle. Very good. Okay, so what I'm going to do this in another color. I'm going to start at this vertex. Now watch what I want to do. I want to split this angle. Now I have to eyeball it a little bit because I don't have like a protractor, and I really don't have a way on here on this program to tell exactly where the middle is. Okay, but here's what I'm going to do. Everybody's looking up here. Okay, Terrell, what are we going to do about this? What should I do about it? I don't know. All right. No, I was talking about Terrell. So what should I do about that? Because he's just not paying attention. But I guess that's his problem. As much as I hate to go on with people not watching, I'm going to. All right, this red line right here. What I did is I eyeballed it. I tried to look to see that I made these two angles equal. So I tried to split this angle into two equal angles. You see what I did? Yes? Okay, so I drew this line. It's actually a ray. Remember that? It goes from a vertex and it keeps on going in one direction, so it's technically called a ray. But I made this ray so that this angle right here and this angle right here would be equal to each other. Okay, I eyeballed it. It may not be perfect, but it looks pretty close. Would you agree? Yeah. Let's name this thing. I think it's very important to understand what the names of these things are. So what did we do to that angle? We did something to an angle. So the first thing is angle, all right? It's an angle blank. What did we do? We split it into two equal angles, correct? We've used that word before. What is it? Segment? No, there's no segments here. That's a ray. We split it into two equal ones. We've used that word. No. It's not isosceles. Are you just making words up? Oh, no, it's not equilateral. I don't have anything about equal sides. I got two equal angles here. It splits it into two. Two. What's the prefix for two? Bi. So it does what? It bisects. That's right. It's an angle bisector because it bisects the angle. What does that mean when I say it bisects? Not just in two equal parts. That's right. It splits it into two equal angles. So when I say bisects, it specifically means it doesn't just make it into two angles. It makes it into what? Two equal angles. Bisects. All right, so this bisects this angle. So I call this ray, see that red thing right there? That red with the arrow on the end? That's a ray. I call it an angle what? Bisector. Okay, I put an S on the end. We'll just call it a bisector. So this is called an angle bisector. Why is it an angle bisector? Because I did what? I split it in half. Okay, that's a good way to say it. Okay, or I split it into two equal angles. That's probably a little bit better to say it like that. All right, so an angle bisector splits an angle into two equal angles. So what if that whole big angle was, I don't know, 80 degrees? What if the whole big angle from here to here was 80 degrees? What's this little angle here going to be? It's going to be 40. That's right. And what's this angle going to be? It's also going to be 40. How'd you do that? Split it in half. It bisects it into two equal ones, so we just took 80, divided it by 2, and we got 40 and 40. Everybody good with that? So that's a what? Angle bisector. So, what have we been doing in this chapter? We took a triangle. What was the first thing we did? Let's review a little bit. In fact, let's write it over here. What's the very first thing that we did? We took a triangle and we found the what? Perpendicular bisectors. I'll shorten that and just put PERP. Perpendicular bisectors. See, we have used that word before, haven't we? But in this one, we are bisecting the side of a triangle, right? This one, what are we bisecting? An angle, right? Okay? So, when I found the perpendicular bisectors of a triangle, all three of them, they all meet at a point. What do we call that point? The circumcenter. Circumcenter. Okay? There's 4 things we're going to have to memorize. All right? That's the first one. We've talked about that a lot. We've talked about this one a little bit, not as much as perpendicular bisectors, but we have talked about it a little bit. What if I find the altitudes of a triangle? They all meet at a point. All 3 altitudes will meet at a point, and we give that point a special name. What is that point called? What is it? Orthocenter, right. Orthocenter. Okay? Now today, what do you think we're going to do? We're going to take a triangle, and we're going to do what to the triangle? We're going to find the angle bisectors of all 3 angles of a triangle. Okay, so we're going to do an angle bisector. Do you remember what that's called? It was the title of the lesson. That gives us the incenter. So those are 3 things you're going to have to memorize. Okay, know that perpendicular bisectors goes with circumcenter, altitudes goes with orthocenter, angle bisectors goes with what? Incenter. All right. There is a 4th one. We'll do the 4th one tomorrow. Everybody got it? Okay, so now let's show you the incenter. So I'm just going to draw some random triangle. Okay, there's a nice little triangle right there. And what do you think I'm going to do to all 3 of these angles? Well, I'm not going to find the incenter of the angles. What do I do to that angle? I bisect the angle. Very good. All right. Now, you got to be careful with this because I don't have a protractor. I have no way to really measure that these angles are equal to each other. I just have to eyeball it. Okay, I'm just kind of guessing. All right. So, would that be a good guess? Would that bisect that angle down the bottom left? You guys up here. Would this bisect that angle? Does that split it into 2 equal angles? That does? No, it doesn't go to the midpoint. It never said anything about going to the midpoint. What do I have? Look at this angle right here. Does that split it into 2 equal angles? No. Does that split it into 2 equal angles? No. It's got to be somewhere where? In the middle, right. Somewhere about, I don't know, right there. Does that look close? Like that? Or like down? Like there? Okay. He does. So, watch. So, I tried to make those 2 angles the same. I got another program where I could actually make them exactly the same. I used that with my honors class earlier this year, and they said it was too confusing, so I thought I would just go to this for you guys, since they thought it was too confusing. All right? So now let's go from here. Let's bisect this angle. So, oops, that didn't start very well. Let's start right at the vertex. Okay. Now, what am I trying to do? I'm trying to split this angle in what? In half. That's right. So where do you think? Do you think it's there? Do you think it's there? It's probably somewhere around here. Now, I don't care. I'm not looking to see where it hits the other side. Where am I looking? I'm just looking here. Okay? Everybody see that? I'm looking here to see if it splits it in half. Does that look close? That looks close enough. Maybe. All right, so that means that this angle and this angle are equal to each other. Might be off a hair. That's good enough. Now check this out. when I do the third one, guess where it's going to meet? Right where those other two meet. Do you see it? Okay. And so, and check it out. This is a little bit better than what I did in the other class. So this angle and this angle are equal to each other. So what did I just draw? What did I just draw? I haven't even talked about where they intersect yet. Okay, what did I just draw? What did I draw here? What did I draw here? Bisectors. What kind of bisectors? Angle bisectors. Okay, so I just drew angle bisectors. Everybody with me? So I split each of the angles in half, right? And guess what? They just happen, not really. Okay, this is actually, it's kind of cool that this happens. Like, nobody made this up. That's what's interesting about this. Okay, you take any triangle at all, and you split the middle of every triangle, it's always going to meet at one particular point. Right? No matter what triangle you use. Now, sometimes it's going to meet on the triangle. Sometimes it's going to meet outside the triangle. Sometimes it's going to meet inside the triangle. All right, but it's always going to meet, which I think is kind of interesting. All right, everybody with me on that? So what do you think you call that point? That's called the incenter. I know we wrote it down before, but I'm going to write it down again. Okay, that's called the incenter. That point right there, that's the incenter. You with me? Okay, now, let's review a little bit. Let's go back to circumcenter. Remember you did the perpendicular bisectors, you got the circumcenter. Remember what we said was special about that circumcenter? I think we always drew it in yellow. We said that the distance from the circumcenter to the equidistant to the where? All the vertices. Very good. Okay, so the circumcenter was equidistant to all three vertices. Remember that? I did it in yellow. Go back, watch the video. All right. So we had that circumcenter, and then I drew a line up to this vertex, down to this one, down to the other one. All three of those lines, I think I made them in yellow, all three of those were equal to each other. All right. That was special. That's the one thing that was special about the circumcenter. What was special about the orthocenter? Now, we find the orthocenter by doing the altitudes, but what was special about the orthocenter? There was nothing special about it. Remember me kind of dogging the orthocenter? You're not special. There's nothing special about you, all right? So the orthocenter, there's nothing special about it. Now, these other two things, there are special things, all right? There is something special about this. And you're probably dying to find out, aren't you? Yes, sure. So here it is. The distance, now listen carefully, the distance from the incenter to the three sides of the triangle are all going to be the same. So what is the distance from a point to a side of a triangle? Is it from here to here? Is that the distance from there to there? Is it from there to there? How would I find the distance from this point to this side right there? Where would it be? We've talked about this before. Doesn't sound like you remembered, but I'll put it here anyway. It's the perpendicular distance, okay? From here to here, that would be the distance from that point to that side. Okay, if you go perpendicular, that's the distance. So what's the distance from this point to this side right here? What would I have to do? That kind of looks perpendicular right there, doesn't it? So that distance right there, that's perpendicular. What do you think is true about these two yellow ones? Okay, they're perpendicular, but more than that. What did I say? They're the same what? Distance. So look, if I made this perpendicular, what's true about those three yellow lines right there? They're all the same distance. So the theorem on this, okay, or the incenter, I guess it's a theorem, says that the incenter is equidistant. We've used that word before, haven't we? is equidistant from the three sides of the triangle. All right, so this point right here, it's the same distance to this triangle, or to this side, as it is to this side, as it is to this side. So all three of those yellow lengths are the same. So what could they do on a homework problem? Well, they might say like that length is 3. So what is this length? Nobody? It's 3. What is this length? It's 3. If they give you one of them, the other two are exactly the same. Make sense? All right, so that's what's special about the Incenter. What's special about it? It's equidistant from the sides of the triangle. You're writing this down? From the sides of the triangle. Okay, that's what's special about it. That's right. And how do I find the distance from a point to a line? It's perpendicular. Okay? We've talked about that before. Even when, like, watch. What if I just had some random line and some random point right here? What would I say if I asked you, look, everybody look up here. Let's say that's you. You're standing right there. And I say, what is the distance from where you're standing to the, I don't know, to the side of the building, okay? Pretend you're looking straight down, right? This side of a building. Okay, what is the distance? How far are you from this building? How would you measure? What would you measure? Would you measure to here? Would you measure to there? If everybody wanted to get the same measurement, what would the measurement be? Straight down. Okay, but give me a better word than straight down. Perpendicular. That's right. So that is the distance. Okay? The distance from a point to a line is the perpendicular distance. That would be the distance. Okay? So come back up here. What is the distance from this point to this line? It's the perpendicular distance. Same thing here. Same thing there. So those three distances are equal to each other. How did I get 3 of them? I just made it up. I said, what if? I said, what if the length of that was 3? I could have picked any number, okay? So if this was 3, then what's this one? It has to be 3. What's this one? It has to be 3. Make sense? Yeah? Okay. So that's pretty much it for Incenter. So what I'm going to do now, and I did this for the other class, and I think this is a good review for us. Well, actually, I'm going to keep recording. I'm going to tell you one more thing. Remember I said we weren't going to do that part B today? I do want to show you one quick little thing about it. So, yeah, let's draw a triangle. I'll do this tomorrow as well, all right? But there's one question on number 1 where you kind of have to know this, all right? Yeah. Yeah, anything that I say up here is always fair game for a quiz. Okay, watch this. So we've learned, let's go through some of the words we've learned. We've learned perpendicular bisector, correct? We've learned altitude. We've learned angle bisector. The fourth one is called median. I'm going to teach this tomorrow again, but I'm not going to get into great detail on this. Median. You ever drive down the road, especially on a highway, and you got that middle section you can't drive? What do we call that thing? Called the median, all right? That's called the median. It's called a median for a reason, because watch, here's your road, right? There's the side of the road, all right? And this is like a little grassy area. Everybody see that before? Right? And here's the highway. Here's the highway. Where is the median usually located? In the middle, right? So we use the word, what? Median to indicate that's in the middle. So watch this. What if I found the middle of this side? That would be the what? No, just that point. Just that point. What's that point? No, just that point. Just the point. What is that point? Come on, guys. You're killing me. You guys been doing so well today. What is it? Yeah. Okay. Because watch. If that and that were equal to each other, what's that point right there? That's the midpoint. Do you agree? So check this out. What is the median? The median goes from a vertex. Where do you think it hits? No, it's not perpendicular. This is different. Okay? If it was perpendicular, then that would be the altitude. It's not perpendicular. Okay, this is a different word. It's median. Where do you think it hits? I've given you all the hints in the world. At the midpoint. That's what I want you to say. Okay, at the midpoint. All right, everybody with me? Sure you are. So look, I go from a vertex to a midpoint. What do we call that thing? That's called the median.
I was going to say angle bisects.
It doesn't necessarily bisect the angle. Look. Everybody look. The median is different from the angle bisector. The median hits the midpoint of the opposite side. It says nothing about bisecting this angle right there. Just because this is a median does not mean that this angle and this angle are equal to each other. You with me? It just hits the middle. That's all I want you to know right now. Tomorrow we'll get more into it. All right? Centroid. We're going to talk about that tomorrow. Okay, that's why I said I only want you to know what the median means right now, because there's a question on the homework number. What number is it? Is it number 1? Probably. Yeah, it's number 1 on the homework, and it's going to ask you for all those. Okay. All right. I'll keep this thing recording. There's no reason to stop it, I guess. Let me draw the triangle that looks like number 1. So here I am. I'm doing a homework problem. Well, I'm going to say with you, not for you. So you shouldn't just be writing down the answer. You should be thinking along with me here. All right. So this kind of looks about like that. This kind of looks like that. All right. And let's put some letters in here, X, Y, Z. So this is X, that's Y, and that's Z. All right. So let's do this. I'm going to put the midpoint right here. And I'll do these in different colors. Make it look all pretty. So watch, I'm going to go from the midpoint perpendicular to this side right here. So, what do you think I call this thing? What do I call that? It doesn't go, I mean, it does hit the midpoint, but it doesn't go to a vertex, does it? This is a what? You said it, Martin. Say it. This is a perpendicular bisector. That's right. Why is it a bisector? Because it splits that in two. No, it doesn't split the angles. It splits that line segment into 2 equal line segments. You got that? So what is that red one? Perpendicular bisector. Okay. This is kind of review. That's what they're doing on this problem. They're kind of reviewing all these things. All right. What about this one? What if they took this, and I'm trying to split this angle in half? All right. So I'm going to go to about right there. Does that look like it splits it in half? Pretty close. So this right there. Yep. I should write these down, shouldn't I? So that's the angle bisector. And this, again, what do we call this thing? Perpendicular bisector. Let's put it outside here. I'll just shorten that. Perpendicular bisector. Okay, good. So we got 2 things. Let's do a third one. Let's do which one's the outside? Okay, let's do this one. Let's go from this vertex, but I want to go perpendicular to this opposite side. Okay, I'm not hitting at the midpoint. I'm not trying to bisect the angle. I'm trying to just go at a right angle perpendicular to that side right there. Yep. That green one is called the what? The altitude. Did I spell that right? Altitude. Yep. All right, so the green one is an altitude. How do you know that? Because it goes from a vertex where? Perpendicular to the opposite side. Now we got one more. Let's do that in yellow. Actually, I got to do this first. First of all, I got to find the midpoint of this line segment, and that would be right there. Okay, so that's the midpoint. Now check this out. I'm going to go from a vertex. Where do you think I'm going to hit? At that midpoint. I'm going to hit at that midpoint right there. Everybody see that? So this is a midpoint. So this and this are equal to each other. So what do I call the yellow one? From a vertex to a midpoint. We just talked about it. That's a median. That's right. So the yellow one is called a median. And that's basically number 1 on the homework. All right. Now they put some more letters in here and they say, which one is the angle bisector? I'll tell you what, let's just put some letters in here. They might not be the same letters in the book. We'll call that A, we'll call that B, call that C, we'll call that D, we'll call that E. All right. So here's the question. And now again, these letters are a little different than in the book. So don't copy down these letters, but it's the idea that I'm looking for. So what is the angle bisector here? Tell me which one is the angle bisector. AY, right? Or YA, doesn't make any difference. It's a line segment, correct? You could say ray if you wanted to, but line segment AY, okay? What's the altitude? EX, okay, good. EX, put a little line segment over top of it. Let's do the median. Which one is the median? Right, ZD or DZ, doesn't make any difference. Okay, and the last one, perpendicular bisector, would be what? CB. So that's the kind of thing that they're asking you to do on number 1. We good? Pretty easy. Now again, I drew it a little different than what the book does, but it's the same idea. And then they got some other questions for you to answer after that. You have to do a little bit of math, a little bit of algebra towards the end. 6 and 7, you got to do a little bit of algebra. Of course. Like, for instance, look. Remember I made all those 3? Remember that? What do you think I could have done? I could have said that this was x plus 2, and I could have said this was what? 3x minus 1 or something like that. Okay, then what would you do with those two? You'd set them equal to each other, right? Let's make that a 2. All right, so you set them equal to each other. Let's do that. So this one would equal this one, correct? Because if this was 3, then this would be 3. But we don't know that they're 3. We know this is 3x minus 1. We know this is 2x plus 2. But we should know that they're equal to each other, correct? So let's do it. Let's do some algebra. This is what I mean by doing an algebra. It shouldn't be that hard for you now. It shouldn't even bother you now. So these two are equal to each other, correct? So you set them equal and you do some math. What's your math? Well, you subtract 2x from both sides. Add a 1 to both sides. Okay, 3x minus 2x is 1x. That cancels. These cancel. 2 plus 1 is 3. So what's the length of this then? It's not 3. It's 3x minus 1. I just found what x is, so how do I find this length? 3 times what? 3 minus 1. 3 times 3 is 9, minus 1 is 8. So this is 8. What does this got to be? That's got to be 8 as well. Let's see if it works. 2 times 3, 6. 6 plus 2, 8. Yep, they're both 8. What would this one be then? That would be 8 as well, because all 3 of those would be equal. So that's the kind of stuff that they could give you. And I could give that to you on a quiz. I got no problem giving that to you on a quiz or test. All right, enough of that. Divide it? I don't have to divide anything because 3x minus 2x is just a 1x. I don't have to get rid of that 1. I just get x equals 3. All depends on the problem if you have to divide anything. Well, in this case, like if it came out to this, watch, if you came out, now this doesn't come out to this, but what if it came out to 5x equals 15? What would you have to do? Then you would have to divide, correct? Okay? But in this situation, 3x minus 2x is just 1x. I don't have to get rid of that 1. I already got x by itself. I don't have to divide anything. Got it? But there are times when you have to do this. So you got to divide it, and x equals 3. We good? All right, enough of that. So what I want you to do is 1 through 7. 1 through 7. It's different than what the lesson plans gives. All right? Made a change on the fly today. So you're only doing 1 through 7, and it's section 5, 2A. And it's on page 217. Page 217. So that's your homework right there. I already did number 1 for you, basically. All right? But that's your homework. Again, it's different than what it says on RenWeb, okay, or FACS. So make sure you make a note of that. It's only 1 through 7. Tomorrow we'll do the rest of them. Everybody good? All right. So we've learned 3 out of the 4. So tomorrow we're going to learn the 4th. And hopefully you'll be able to keep track of all that stuff.